Okay, folks. So one thing that I thought was pretty neat was this thing called Langton's ant. So it's kind of like Conway's Game of Life, only instead of multiple things that are alive, you just have one, and it's an ant. And this ant has superpowers, and it can create death from life and life from death, I guess. So the algorithm basically is like this: the ant always moves forward, but the color of the tile changes. So what I did is I made this matrix called ant pile, which is a double vector here, and I do ant pile as new int life size 1, life size 2, and so I'm pretty sure it looks like it's not fully rectangular. It's 750 by 500, and so the number of pixels is 750 by 500. Here's the size function here. This is using a program called processing, and so there's a void setup routine and a void draw routine. And so the setup routine runs once, and so it sets up the size, the background color, and it sets up this ant pile here. And then void draw runs over and over and over again. So I do iteration plus plus. Int m, what I do is I grab the y coordinate of the mouse and then set the frame rate according to where the mouse is. Set the background to 255, and then what I do is I take that ant pile and I send it to this function called spy. And so spy is down here. And so what I do is I do a double for loop through that matrix there. And basically if the square is equal to 1, I make the square a certain color, and I draw a square there. If the ant is actually there, I draw it in a different color. So basically you'll see everything will be white except for live squares. And then there will be this is RGB, so there will be a blue square for the current location of the ant. So what happens is that, let's see, so I spy that, and then I draw some text. So 000 is all black, and so I say the iteration number and the frame rate. So the ant moves forward. So if the current location that the ant is at is a 0, it becomes live. Then if not, it dies. So basically the ant kills anything that's alive and then makes something alive wherever it's not. So then I move the ant forward. So the problem with moving the ant forward is that the ant can actually turn as well. So if you go down to plus here, what I do is I take the ant and I add the direction. And so what's the direction? So if you look here, what I do is I just add those two vectors together in this plus routine down here. So what does the direction mean? Well, if the ant pile is dead, the ant turns left. If the ant pile is alive, the ant turns right. And then that's basically it. So if the current cell is dead, it becomes alive and then turns right. And then if the current cell is alive, it kills it and then turns left. And I might have gotten that backwards, but basically, if you want, you can if you Google Langton's ant on Numberphile, they do a pretty cool video about it. But I just wanted to show you how to code it in processing. So there's all these vectors here, the void setup routine, and all that. So if you hit play here, the whole thing is going to kick off. So what I'm going to do is I'm going to put my mouse down here at the bottom so that my frame rate is 2. If you look in the upper, I don't want to move my mouse, but if you look in the upper left, the frame rate is 2, and the iteration number is going up slowly. So if I increase my mouse here, it'll start to move a lot quicker. But basically, what you see is that blue square is the ant, and the all of those other cells are basically alive or dead tiles. And so if I keep going here, you can see the ant kind of goes on its merry way. You look at the iteration numbers in the thousands, and it looks like it's seemingly random. This is the cool thing that I when I watched the Numberphile video on Langton's ant, I was like, I will wonder if I could code this and see this for myself. And so the whole point of Langton's ant is that the whole thing is seemingly random. I mean, it's 2 rules. I mean, it's like, if it's dead, it's alive, and if it's alive, it's dead, and then turn left or right. And so the whole thing seems seemingly random, and for basically around 10,000 iterations, it does. And then all of a sudden, boom, it does this repeating pattern out of nowhere. And so it'll just keep on repeating literally forever. And basically, I didn't put any error checking in here. So when it gets to the top, it's going to freak out and it's going to throw an out of bounds exception. But when I watched that YouTube video, I thought this was really neat. And so I wanted to see it for myself. And so I coded it in processing. I probably could have coded it in MATLAB, but processing is a pretty good game engine because it has this built-in void draw loop. And so if you're doing animations, you might want to consider doing processing instead of MATLAB. It's just another language that you can learn. So I hope you enjoyed this. This is pretty cool. Just as a bonus, I'm going to go ahead and show you Conway's Game of Life in here, which is the game. You know, if you notice, I kind of wrote these around the same time. I've got like the frame rate and the my life functions, and here's the spy function. Everything's kind of the same, but you run this, and here you go. Here's Conway's Game of Life in processing. So that's just a little bonus at the end. Basically, the function's exactly the same as the MATLAB video that I posted before. So anyway, happy coding. I think this is pretty neat. Maybe I should just go off the deep end here. Let me show you some other cool stuff here. What do I have? Mandelbrot. Here's some Mandelbrot sets. Here is Mandelbrot converging. So basically, every time the color changes, it's doing a new iteration, and it's doing a color code based on that, which is pretty neat. And look at that. I mean, it's just like totally converged, which is pretty neat. Yeah, I guess I have like a complex. Is complex a type of variable? Did I create that? I haven't looked at this in a while. Yeah. Oh wow, I made this complex number toolbox. Man, look at that, making classes and stuff. Yeah, because basically, Mandelbrot sets are weird because what you have to do is you have to -2. I don't actually know what any of that is. It's been a while since I did this. If you think this is really neat, I mean, just post in the comments and I'll make a video on this. There's even something called Julia sets, which is very similar, but it depends on your initial condition. And so sometimes you'll get like these disconnected sets like this, but every now and then, depending on the initial variable, yeah, you'll get. Oh no, it looks like that's pretty disconnected as well. Or maybe I have like the colors set up too high. Maybe not. There we go. There's a connected set. I don't actually know what that is, but apparently Julia sets are completely different. I randomly initialized the functions there. I think Mandelbrot is probably the coolest one. That one's definitely pretty badass. I mean, it does the same thing every time. I would just Google Mandelbrot set if you're curious about what this is. What else do I have here in processing? Angry ellipses, Mandelbrot. I got a Garmio. I kind of stole a Gario. There was like a huge craze about it. Everybody was like super excited about it. So I made my own. It's really easy. You always win. You move the mouse to eat things. Sooner or later you hit you just get so big that you just like blow up and take over the universe. So, anyway. Alright. I think I'm going to stop here. Happy coding.